Over.
Okay.
Hi, everyone. Welcome back to episode 4 of the AI co-learning program. I'm your host, Bruce. So in today's session, we're diving into the fascinating world of reinforcement learning, or as we like to call it, learning from experience. We'll explore how intelligent systems can improve themselves based on real-world feedback and discuss how these principles apply to applications. Today, our guest is Dr. Yuxi Li, who worked with Rich Sutton, one of the founding figures of reinforcement learning. Dr. Li's work spans from theoretical foundations to innovative applications. So today's talk will guide us through the core concepts of learning from experience, discuss key challenges in data collection, simulation, and model integration, and share Dr. Li's unique insights on the future of AI. So please join me in welcoming Dr. Li.
Yes. Thanks a lot for the warm introduction, and it's my pleasure to share my understanding of learning from experience and reinforcement learning. So this year, the Turing Award was awarded to w.r.t and Rich Sutton. And Rich Sutton from Alberta. I was studying at Alberta. That's my. I feel very proud of it. Actually, it's overdue a little bit. I think. AlphaGo. I think when AlphaGo came out, I think reinforcement learning. Lots of people are thinking when reinforcement learning will have the Turing Award, but finally this year it's awarded to Rich Sutton and Ivato. So this is a very brief introduction of reinforcement learning. Agent environment, agent at some state take action and then transition to next state, and also get a reward. And the goal is to maximize the long-term reward. This is a very general model. It can model many applications. Actually, it's basically about sequential decision making, and actually many problems they can be modeled as sequential decision making. I just very briefly mentioned the rules of reinforcement learning. On the left, you can see the power of dog conditioning. It's basically the animal learning, and reinforcement learning has a root there. Actually, Rich Sutton he got the bachelor from Stanford in psychology and PhD in Massachusetts in computer science. That's maybe a natural reason this reinforcement learning has roots in animal learning. And another important root is optimal control. Yes, like dynamic programming, like Markov decision process. So I put this book. It's a new one. It's lessons from AlphaGo for optimal model predictive and adaptive control. Probably you know that Yang LeCun, he always diss reinforcement learning, and he praise model predict control. Actually, from this I want to see even people like Yang LeCun, the Turing Award in deep learning, may not know reinforcement learning very well. Actually, model predict control is kind of model-based reinforcement learning. So, and they have lots of connections. And another is learning to predict by the method of temporal difference. This paper is very important, and it's one important paper so that Rich Sutton got the Turing Award. And so the animal learning, optical control, and temporal difference, these are the important rules of reinforcement learning. I believe you are familiar with machine learning, so I won't say much about this. So there are super learning with labels and super learning without labels, and the current popular language models, they are self-super learning. So they are basically generative pre-trained transformer with next token prediction. Just using next token as the label. So this is self-super learning. It's something between supervised and unsupervised. And here is just a very brief taxonomy of different categories of machine learning and also AI. The left is basically copy from wiki. The right is from a popular textbook by Russell, Stuart Russell. And we can see here supervised, unsupervised, and reinforced learning, and also deep reinforcement learning. And they are machine learning and they are part of artificial intelligence. So AI is a big topic. It covers many things. And here I basically want to say super learning make predictions, and it's basically myopic and based on label data because it's just for one step. But reinforcement learning make decisions and is long-term thinking on the data points in the form of state action reward next state. Yeah, here actually it's not in a clear cut. Even super learning, sometimes maybe imitation learning. I will talk about that later. But imitation learning is also about learning a policy. So in this case, imitation learning or super learning for the trajectory is not just myopic, but that's kind of a special case. But when we say super learning is myopic, usually we say it's about the say regression or classification for the single step case. And here is a simple example about sorted paths. And consider we want to go from B to F. We want to find the sorted path. Say if we want to go to the nearest neighbor C, then we cannot find the sorted path. We have to go to D, even it's longer than C. But in this case, this is about a delayed reward. So it suffers short-term reward to gain more long-term reward. So reinforcement learning can figure out how to go to D first and then have a shorter path. Shortly after the Turing Award announcement, David Silver, the first author of AlphaGo, and Ray Sutton. David Silver was the PhD student at Alberta. They published the Welcome to the Era of Experience. And they basically say we experienced the era of simulation, for the AlphaGo time, and era of human data, basically the ChatGPT time. And we are entering the era of experience. So experience is critical for further progress in AI, including language models. You can see that lots of people are working on post-training with reinforcement learning. So it's kind of starting to do this kind of research. But yeah, I will discuss that. It's probably not enough yet. This is kind of interesting. Ivanka Trump, Donald Trump's daughter, also mentioned that the most important thing you can read about AI this year is this Welcome to the Era of Experience. She is probably a business person, but anyway, this is from her Twitter account, so you can even find it on Twitter. Yeah, shortly after the Welcome to the Era of Experience, I wrote a blog. Basically, I want to say there are still issues. For example, we have to pay attention to the importance of ground truth and the difficulties of generalizing, transferring achievement in games, math, and coding to other problems. Games, math, and coding, they are very special problems, and many problems are not so easy to just use the techniques in games, math, or coding to make them work. And yeah, I also mentioned ground truth, objective, model-based error, digital versus physical. There are quite some issues in the blog, so probably I won't say in details, but you are welcome to check my blog about this comments to Welcome to the Era of Experience. Basically, I think I hope to give some more practical viewpoint about how to learn from experience. Yeah, this is Probably many people are talking about skin loss, and they refer to bit lesson. That's from Ray Sutton. It's a very famous blog by Ray Sutton. But many people, they don't know the opinion by Ray Sutton on language models. Yeah, here you can see it's actually very critical. It's basically Ray Sutton regard language models as disappointing, superficial, and sucking the oxygen out of the room. Yeah, I put this on YouTube. If you're interested, welcome to check it out. So there may be the issue like truth or trend, whether we pursue the truth or whether we follow the trend. I think, especially after ChatGPT, I think lots of people are following the trend rather than seeking the truth. And there are maybe I think it's not easy to figure out why, and there may be many factors. And I try to put some books. One is the Crowd, a study of popular mind, and another is narrative economics. It's by the winner by Rob Siller, a winner of the Nobel Prize. He had a popular book called Irrational Exuberance. It's before the dot-com bubble, I think. Yeah, and yeah. So, but when we say narrative economics, basically it's about telling story. But telling story is that truth or not? Probably, maybe it may not be truth, right? Maybe it's just the trend. But the crowd thinks so, believe it, and the crowd try to just, for example, in the say AI world, people trust something, and lots of people trust something. Then that's the story, and people trust it. Then it's that may be a bubble. Yeah. Here I want to this kind of like business cases. One is basically it's about deep learning. It's about reinforcement learning. AlphaGo 2016, and then 2020 GPT-3 paper. GPT-3 paper got the outstanding paper in Europe, and also the RRHF in ChatGPT, and in the end of 2022. But sadly, DeepMind Alberta was closed at the early 2023, just after the launch of ChatGPT. Yeah, I wrote a blog. I think reinforcement is very important for language model. And in September 2023, the Keen technology was created, and John Carmack basically invested in Ray Sutton. And then in 2024 September, OpenAI O1, and in January this year, DeepSeek R1, and in those two models, reinforcement learning play important roles, and like in post-training. And just 2 months later, March 2025, Ray Sutton and Alberta got the Turing Award. So and then in March 2025, Sequoia Capital, they have the first YouTube about reinforcement learning. Yeah, from here I want to say, so how the business people, even research people, they make decisions about reinforcement learning. I think there was something wrong. For example, should Google close DeepMind Alberta? Ray Sutton was one of the leaders for DeepMind Alberta, and should like top VCs like Sequoia Capital started to talk about reinforcement learning this late, early 2025, but not in 2023 or even 2024. I think something wrong here about the importance of reinforcement learning. So that's let's go back to the truth or trend, whether people what kind of people are following or seeking. That's a problem. And on this one, another business case is especially for Meta. Zuckerberg running through Tiananmen Square, and in 2019, Facebook created Libra. It's a stablecoin, but especially just fully decentralized. So it didn't care about government, but the government just stopped it. So 2020, the GPT-3, the best paper, but Facebook in 2021 renamed to Meta and all in Metaverse, and then ChatGPT, and then become ETF, and then Meta acquires Skill.ai with lots of money and hired people, AI expert with huge amount of salary. So whether this is a good decision or not, I think for me, I think that's a big question mark. Especially if you want to do super intelligence, whether people doing data labeling are good enough or not. Maybe let's come back in 1 or 2 years or 3 years to see how this decision is. But Libra and the Meta, these two decisions, at least at this time, they were probably not very good. And for Sam Altman, he said something like new Moore's law, but 2023, that's the genesis of AGI. 2024, the genesis of language model applications, and 2025, genesis of language model agents. But language models still make simple mistakes, and they cannot solve even basic arithmetic problems perfectly. So there's still something wrong with the language models, and I don't think those promises are fulfilled at this time. And maybe we need to worry something about the progress of language model. Yeah. So AI are good for fun, for toys, for demos. Yeah, they make some progress in some enterprise, but is that good enough? I think they still need some time to demonstrate its success. So, and there are also lots of things we need to improve. So I'm thinking, following the say learning and learning from experience, those principles. So when we build AI, it's very language model. What are the first principles? So here I basically summarize two. One is ground truth. So what's ground truth? Here I identify three sources of ground truth. First one is perfect verifier with formal method. For example, in math, in coding. In these cases, we have perfect verifier, since they are based on the axioms. So perfect reasoning systems. And another is perfect rules, laws, or world models. For example, in games, like Go or chess, or maybe in the Newton world. Maybe in that case, if we just assume Newton is perfect, then that's okay. But if in the quantum world, Newton physics are not perfect. But if we assume Newton is good, then that's okay. That's okay, under this assumption. But like chess or Go, these are how perfect rules. So these are, in this case, we have ground truth for those cases. And another is experience by interacting with the world. So in this case, we can regard the world as a perfect model. So interacting with the world, we basically collect data with a perfect model. But in this case, it's kind of sometimes it may be noisy, and there may be, say, adversarial cases. So we need to be more careful. It's messier than the first two cases. And here are some examples. But you can see nowadays people, for example, when people are developing coding language models, they may do several tests, they may do executions, and then they treat those as correct. But these say several tests or several executions cannot guarantee correctness. They may not cover all the cases. And for math, if just matching the scalable results, that's probably not enough. So it cannot guarantee the correctness of reasoning types. And for NLP problems, many of them, they don't even have objectives. They are subjective. So people created Brute-score perplexity, those performance measures, but these are heuristic. They are not the true performance metric, but people just try to make things easy. But these are not ground truths. So there may be something wrong. Even we are using machine learning to optimize those objectives. So this slide, I want to say the current practices. There may be something wrong with the ground truth. So we may have to do something to improve this. There is a Harvard Business Review article. It's about what gets measured AI will automate. So basically, it's relevant. And another principle is iterative improvement. If you think many success systems, they make iterative improvement based on ground truths. So you can see there are, for example, from the gradient descent in optimization and to many learning algorithm and to even software development, or even to the evolution of our humankind. So all those systems, they make iterative improvement, and hopefully with ground truth, so that they know how to improve. But the current learning models, they fail one or both of those first principles. Either they have weak or no ground truth, or they make infrequent updates, either months or even years. Say the GPT-4 to GPT-5, it takes more than 2 years. That's too long, right? So yeah, there are several other models in between. But even for those, it usually takes several months. So probably we hope to do something to improve the model more frequently. Yeah, we switch a little bit. So here I want to ask, very simple, very basic question, very intuitive question. So can we learn swimming by just reading books or just by watching videos? Probably no, right? Or it should be no. We have to jump into the water and play with the water and even drink some water to learn swimming. We have to interact with the water to learn swimming. So there's a paper talking about the 5 level of world scopes. This is about different data. So in the inner circle is basically the small scale label data, and then internet text, and then multimodality, image, audio, video, and then it's about embodiment, or it's about interaction with the physical world, and then the social experience, interaction with the social world. So we to have a full intelligence, we need all those 5 world scopes, and so we need those to have grounding, we have meaning, understanding, and we need social experience and embodiment to have agency and goal-directed communication. So especially if we want to do agent, we need interaction with the physical world and even the social world. Yeah, actually, by this, I'm also criticizing the current language model or the current agent. So if we want to build a successful agent, we have to interact with the real world and collect those embodiment of social experience data. Okay, world model is a hot topic, and basically world model is about basically there are 2 parts. One is transition or dynamics model. Another is reward model, and I basically use those concepts from reinforcement learning. Yana Kun talked about this world model, and he has a paper about this. And if you see this, you can see world model, you can see critique, actor, action, cost. This is very similar to reinforcement learning world model. So in reinforcement learning, we have agent, we have world, and we have state action reward. And the right is a more detailed graph of agent. This is from article by Richardson in 2022. Yeah, by this I want to say the true agent should be coming from both experience and the model. Experience is basically data. Data. But model, we need some model to at least improve the efficiency, and we need to combine empiricism and rationalism, and we need to combine connectionism and symbolism to achieve sound and solid grounding and agency. So many people are using language model as a world model or as a policy, in the reinforcement learning sense. But say language model can provide some kind of model, but the problem is how good this model is, how accurate this model is. So there are some papers studying this. The results are not unexpected. The models in language models, the world models in language models are not so good. Yeah, and it depends on different problems may have different level of accuracy. So we do need to check whether how good this world model in the language model is, rather than just rely on it and for example generate data. And usually there since the world models are usually learned and not correct, so there is usually a simulation to reality gap. Simulation is based on the model, and so we need to bridge the simulation to reality gap. There are many techniques, and so so this is my understanding. The language model is not perfect, but there is a model to reality gap. So the prompt engineering, this including I treat if a technique doesn't change or update, improve the underlying language model, then I call it prompt engineering. So chain of thought, React, RAG, those techniques, they are prompt engineering. So they can probably wield as ways to bridge the simulation to reality gap. But they are heuristic. They are not very principled. And synthetic data is a popular topic. So can they help? Will they help? I think it depends. If the model is perfect, for example, say chess or Go, these have perfect models, then the data generated from those models, that are perfect. So that's good. If the model is not perfect, then there may be something wrong. So we may have to bridge the simulation to reality gap. So language model is in this case. Language model are not perfect model. So we need to be careful whether the synthetic data is helpful or not. So for the mathematical problem, since they are based on perfect axioms, so the data, the synthetic data using mathematical rules, theorems, that's good, that's perfect, and it can be fully verified. Then we can fully trust those data. So we have alpha geometry and alpha proof, and those systems can be built on synthetic yet perfect data. Yeah, Dave Silver gave a talk in last year, the learning conference. Basically, he says language model alone are insufficient to achieve superhuman intelligence, and super scale learning is a way, and perfect verifiability allow us to generate provable correct proofs. So we need perfect verifiability for provable correct proofs. Otherwise, we don't know, right? Just like many many reasoning or planning approaches with language model, but this cannot be perfectly proved. So there may be something wrong. So AI's proposes autonomy, optimality, and adaptivity. And correctness actually is a prerequisite for example optimality. So we need to achieve those before we say they are good AIs. And nowadays there are something very popular. For example, web coding, and people just use English, as a prompt, and sometimes they do coding or just use language model. But there is a basic problem. A natural language like English is ambiguous by nature. So when a AI system don't have a perfect specification, then how can we expect the AI generate a perfect solution? Because English has ambiguity, so the specification is not perfect. Then the AI system cannot generate a perfect solution. The input, something wrong with the input. So probably we need to pay more attention. Although these are the big trend, many people are doing prompt engineering, are doing web coding, but the problem is English is ambiguous. They cannot guarantee the perfect specification, so we cannot expect perfect solution. This is from a paper by DeepMind. Basically, they have different levels of AGI and different levels of autonomy, and agent is a very popular topic, but agent in this as defined here is the the highest level of autonomy and AGI. So actually, all the agents these days they are not autonomous, they are not optimal, they are actually assistant. Here I introduce imitative learning. Basically, it's learned from demonstration or behavior cloning or apprentice learning or inverse referral learning. And supervised fine-tuning, that's learning a policy, so it's imitative learning. And also the DPO, direct preference optimization. And SFT and DPO, but they don't learn a reward. And RHIF, they learn a reward first and then optimize the policy. But RHIF is inverse referral learning, so it's also imitative learning. Yeah, this figure probably you are very familiar. It's ChatGPT, and here SFT, RHIF, they are imitative learning. Yeah, very brief introduction of AlphaGo, deep learning, referral policy, iteration, self-play, Monte Carlo research, and so why AlphaGo? This series like AlphaGo, AlphaZero, and AlphaZero works. They have perfect model. They have perfect game rules or perfect model. So high quality or even perfect data. And then we can use those perfect data to use referral learning. Like trial and error, general policy iteration, self-play, iteratively improve the policy. And actually, the result actually the AlphaGo, the first version, they use expert data. But actually, say AlphaGo 0 and AlphaZero, they just learn from scratch. They don't use any human data. But actually, they have stronger AI than AlphaGo. So it's a evidence that embedded learning is not enough. So in the AlphaGo case, embedded learning, learning from the expert boards data, the error score is lower than without those human data. So here is it's a paper. It's actually I once have a hypothesis that net token prediction is a image learning. So learning model can do some kinds of reasoning and planning, but it's not a efficient and effective image learning. Because it's just use next token. It's not a very strong label. And even it's a strong label, here, this is the evidence. Actually, I think it's a general topic in reinforcement learning. Image learning is not enough for learning policies. So even net token prediction is a strong image learning. It may not be enough to learn very good policy. So this may be a problem. So we may need to think something beyond net token prediction to have better AI, better language models. AlphaGo, here basically says AlphaGo, just now we mentioned human data. And many problems, including math and coding, although we have made, the language model have make big progress, very good progress. But even so, math and coding, they have not reached the level of AlphaGo or AlphaZero yet. So there is still room. But since they can be backed by formal verifier, so AlphaGo may help here. So we may try to do something with those formal verification and using some technique like AlphaGo. Another thing is mu0, but this is a model based. It works with those games, but it doesn't assume the proof model. It learns the model. Many language model problems we don't have model, so mu0 may be applied to many language models. But the problem of data collection may be very, very costly. And RSF and image learning, we may make them iterative, so that although they are not good enough, but we can make them iterative and gradually improve them. And we can make the system stronger and stronger. To be honest, I covered lots of concept, and maybe in the QA we can talk more. And for some concept we can talk more in detail. And for the language model, there are many papers talking about self-something approaches. For example, self-generation of data, self-evaluation of results, self-improvement of the model, and self-instruct, self-reflect, self-debug. And there are papers about language model as a judge or agent as a judge, those problems. But the problem is language models are not perfect. So if we are using something not perfect to do those kind of self stuff, so basically we are building information perpetual machine. Unless with ground truth, something from external data to input the model. Otherwise, if we just use a imperfect model, we cannot improve a perfect model to a perfect model, right? So otherwise, we have the information perpetual machine, right? That's a problem. So from the principle, there may be something wrong with those self approaches, although they may make some improvement in the, for example, some performance measure, But I think this is a principle, right? We cannot improve something imperfect just based on itself and get something perfect. That's not impossible. Otherwise, we have the perpetual motion machine, right? And learning model powered. Currently we have the learning model powered, but manual heuristic suboptimal AI agents. They are actually assistant or copilot. So we may. So the problem is, I think there's something wrong with the underlying model. And just now we mentioned the next token prediction. It's not efficient and effective in machine learning. So, but we are trying to build reasoning, planning, and agency based on this kind of model. So the base model may not be good enough, but we have to do something. So it's something like we want to build a beautiful garden on a desert. It's not totally impossible, but we may have to put lots of effort, lots of resources to do that. And here is a opinion, but I think the reasoning should be very intuitive. So when we want to optimize many objectives, usually we cannot optimize all those objectives. And when there are many constraints, if those constraints are tight, we may, the tighter constraints, the less chance to find a feasible solution. But what's AGI? AGI is a infinite objective, infinite constraint optimization problem. So we want to have a single model to optimize infinitely many objectives, and trying to satisfy infinitely many constraints. So it's very likely we cannot achieve. We can find a feasible solution, not to mention an optimal solution. So, but actually you can see OpenAI O1, DeepSeek R1, Grok 3, they are actually specialized models because they are focusing on reasoning, and in particular math and coding. And even GPT-5, GPT-5 is working. It's using mixed expert. It's not a single model. It's a model under just using one big neural network. But if you are using mix of expert, maybe we shouldn't call it a single model. But since they are doing multiple models already. Yeah. So this is a common sense in society. The specialist versus generalist, and division of labor and cooperation, right? So usually, if you go to see a doctor, you want to see a specialist rather than a generalist, right? If you can afford it, you'll see the best specialist, right? And in our society, we divide the labors and we cooperate. We are not just using one say one person or one organization to do everything. And here is my proposal. So we do specialized, modular, and maybe smaller models rather than a single one. And here we have many modules, and they may work together with tools, APIs, and there is a module 0. Module 0 may be several of them, but module 0 is a coordinator. And this coordinator can coordinate many modules. And each module is good for one or a group of tasks. And then the module 0 can collaborate with those modules. And all these modules, they keep improving iteratively. So, for each module, the rest is an environment, and it receive feedback from the rest of the world, and keep improving. Yeah, so basically this is a multi-agent system, and there are many of them, and each of them keep improving. And they can be, since they are focusing on one or a group of tasks, they can be much smaller. I think there are many models. They can be pretty successful in some certain tasks. Actually, there are some old models. For example, AlphaGo, for example, AlphaFold. Even Python or calculator, they can do something pretty well. Calculator can do arithmetic problems perfectly, and Python, they can, if people program it, they can do many things very well. Yeah, so we just we already have those models. They, in some sense, they are better than the current language model. And probably we should go this way and build specialized, modular, and smaller models, and they are likely better than the large language model in certain tasks. Yeah, this is GP5. Probably you already know. The mixture of expert. Yeah, here is basically the summary of my proposal. Ground truth and optimal and adaptive, and single model is basically approximation and grounding, interaction, and agency, and bridges simulation to real gap, and iterative improvement based on ground truth, and specialized modular smaller models, and learning and search. It's not, and yet I will talk a little bit more. Time should be, I should be okay. Yeah. So probably you already realized that I'm talking about next gen AI. So gen here is generation, not just generative. I'm talking about next generation of AI. I'm talking what may be a good way to do AI. So this is my proposal. Just now I already gave something, but here is also a summary. We leverage domain knowledge for data, for architectures, for algorithms, and we iteratively make iterative improvement based on ground truth, and we use reinforcement learning and search even in pre-training, not just in post-training. But sometimes we want to reconcile with the current mainstream. We want to do post-training and test time compute. Here is a concrete example. For code learning models. I think the current fundamental problem is the popular code learning models. They treat programming language as natural language, using GPT with network computation. So in this case, lots of reliable information like syntax, semantics, compiler information, like abstract tree, data flow graphs, those informations, those code learning models, they don't benefit from those reliable information. Just from the public information, the popular language models. But there are many papers that are trying to do something. So I'm talking about those big ones, and from the information we know, they are not doing, they are not taking advantage of those information yet. And for the code, we probably we probably shouldn't just do nice token prediction, because there is a hierarchy in code, from word, from statement, for function, for class, for project. There is a clear hierarchy. So we probably should take advantage of this hierarchy to build a better code learning model. And the current training data, there may be errors, and just using test cases is not a ground truth. It's not a perfect evaluation. And in code generation and explanation, there are hallucinations. So probably we should explore and exploit the perfect valuable domain knowledge in coding, and hopefully we can mitigate or even eliminate mistakes and hallucinations, and improve the efficiency and effectiveness. So this is a concrete plan to revolutionized code learning model. Yeah. And another interesting thing is to do the experience data collection. Since David Sierra and Risatan, they wrote the article about welcome to the era of experience. And one important thing is about data. But if we have to interact with the physical world, if we have to interact with people, then how to collect data will be a problem. And how to collect data, high quality data, and in an efficient way, that's a problem. So that's an open issue, but such is an open issue. So there will be it's probably valuable if we can find some way to collect many such data. Yeah, for experience, the experience data for example for games and even for math and coding may be much easier. But if the AI has to interact with the world, interact with people, then the problem will be much harder. And another topic is simulation. Although we have a lot of theories, but those theorems they may have strong assumption. They may not reflect the real world well. So, especially if there are people, if there are human in the loop. So usually, there are behavior bias. So simulation probably will be a good solution to approximate the real world. So simulation is something worth more study. And here is it's a screenshot from Risatan from his summary conclusion slide. The error of human data, error of experience we already talked about. And here I want to say Risatan he highlight the importance of decentralized cooperation over centralized control. Probably this is the direction of civilization. Decentralization is related to democracy, to free market, rather than centralized government, dictator, those things. So probably decentralized cooperation is something we should pursue. So I discuss a little bit about here is a hot topic these days, stablecoin, like the circle. But I think the key factor is stablecoins will likely revolutionize Visa, these credit card and Swift. For the credit card and for the Swift, people pay some amount of transaction fees for them. But if we are using stablecoin, those transaction fee will be much lower, and this transaction will be much faster. But probably there will be many opportunities in the stablecoin, and say reinforcement learning from experience maybe play the roles somewhere. And decentralized AI, that's a big topic. Here I list several. I think those are important. And deep learning for function approximation, reinforcement learning for sequential decision making, cryptography for security, private trust, blockchain for distributed ledger, incentive mechanism for self-use agent to collaborate, and human behavior for biases in human decision making, simulation for analytic and empirical and model and data, so software engineering, to eat the world. So these are, it's a very big topic and it covers many topics. So, but I think probably is something interesting to pursue. And this is basically, some big names, some successful researchers in economics, in computing, and in blockchain, and also actually the first row is economist, and second row is people like Alan Turing and Turing laureates, and the third row I put Satoshi, the creator of Bitcoin, and several very good researchers here. I hope those people, we can build things based on the achievement by those people and to make progress in decentralized AI. Yeah, here's just some recent news. Terstall, the funding in UCLA, and even the IPAM, the Institute for Pure and Applied Mathematics. There may be funding problem with those, say, faculties in UCLA and the IPAM, the institute. And for this genius, 17 years old girl, she saw a major math mastery, but when she applied to graduate schools, 6 reject her because she didn't have a college degree, and 2 admitted but turned down by the higher administrator. So 2 accepted her, and she decided to go to Maryland. But by these 2, I want to say, the current centralized governance or management of research and education maybe needs some reform. So decentralized research education may be a potential solution. Here is this is about AI conferences. Probably many people know that there are lots of problems with the review process, and decentralization may be a promising approach for those problems. Yeah, for education, for research, and for AI conferences. So I will talk a little bit about value investment. I think DeepMind is a good example. At that time, people don't know refining well, but DeepMind did it, and AlphaGo was a landmark in AI. So it's following the trend value investment, like prompt coding language model agent. There are lots of issues. It's not clear whether the current language model just scaling up GPT net competition can solve those problems. But learning may be a value investment, and it's key for autonomous and optimal agents. Yeah, and here I just want to say AI versus IT. IT is basically what you see is what you get. But I think nowadays people using IT techniques to solve AI problems. For example, prompt engineering, for example, workflows, RAG, those things. I think these are basically it's very prompt engineering. That's IT, basically an IT approach. So yeah, I'm not quite sure whether those IT approaches can solve AI issues. Probably we need to improve the underlying model. Yeah, this is a general suggestion. For the VCs, probably they need a scientific committee. Yeah, here is the application areas of refining basically everywhere. And here is a general discussion about why not. Yeah, this is basically several years ago. Basically, it's about why not there are no killer app for refining, but probably we don't have enough precision resources, R&D adoption. Now it's better, but probably we need more, and probably we need more resources. For example, for refining in the pre-training stage rather than just post-training stage. And here is it's ENIAC, like 70 years ago. It's very big, very expensive, but the performance is just so comparing with iPhone much smaller, much cheaper, but much more powerful. So language model maybe still in this ENIAC stage, and how to reach iPhone stage of language model probably needs lots of innovations. Yeah, basically this is my talk. Yeah, thanks for your attention. Any questions?
Okay, thank you so much, Dr. Lee, for the amazing talk. So now let's open up the floor for questions from the audience. If your question is selected, please screenshot your comment in the chat and send it to our official email so that we can verify and send you API keys after the session. So let's see. The first question we have here is, what problem is reinforcement learning used to solve, and what problems can be solved by reinforcement learning?
Okay, yeah. I think reinforcement so far is very good at games. For example, Atari games, Go, chess, or even poker, even StarCraft. And many games, reinforcement is very, very successful. And for chess, for Go, nowadays, no human being can beat AI, and human has to learn from AI. That's I think the main reason is for those problems. We have the games have perfect rules, so reinforcement can learn them pretty well. On the other hand, game reinforcement is a general framework for sequential decision making. So here I put many problems. So if we can have lots of data, the data may be from a say world model, perfect world model, perfect rule, or collect from the real world. If we can find lots of data, then reinforcement learning may probably help. In large language model, probably I should go to that page so you can see that. So in large language model, it's already used even in ChatGPT. In the step 3, this is after pre-training. So in step 3 is reinforcement learning from human feedback, and this is very important for alignment, and I think it's also for other things. But after, let me see where I put it. But anyway, probably you know that. So after OpenAI 01 and OpenAI 01 and DeepSeek R1, lots of people are using reinforcement learning for post-training language models. So these are very interesting applications of reinforcement learning. Either in reinforcement learning from human feedback or in post-training especially for reasoning and for math and coding. So why math and coding? Because those problems can relatively easy to collect good data. So data is still a problem. So once you can have a solution for collecting data, then reinforcement learning may probably be a good solution for that, for the decision making. Yeah, generally. Yeah.
Okay. The next question is, how do you plan to implement multimodal reinforcement learning?
Multimodal. So you're talking about my proposal or this one, right? Yeah, if we are talking about this one, yeah, it's a so it's basically an ecosystem. It's not from not a single company or single person or single organization. One person or one organization, they are doing one or several of those modules, and then they collaborate with other people, other groups, other organizations, and for each module, they will collect the feedback from the rest of this module and from all the other modules and tools, APIs, and tasks, so that when it can collect those data, then it can using some reinforcement learning algorithm to improve it. So all those modules, they are doing this way, and gradually, iteratively, those modules can improve. So we can have better and better modules. Yeah, that's roughly, but that's it's something like a blueprint. So there should be lots of things to think. And I don't think this is a mainstream idea yet. So But for me, I trust this should be the solution, final solution. So yeah, the current gigantic language model probably won't achieve many strong AI, the AI capacity by a single model. Yeah.
Okay, thank you. The third question is, what advantages will learning-based pre-training bring to the current LLM training paradigm, and which has returned to pre-training?
Can you repeat that again?
Yeah. What advantages will reinforcement learning-based pre-training bring to the current LLM training paradigm?
Okay, yeah. I think maybe I let me see where did I put that. Let me put this here. Probably we probably we need to consider many things again rather than just using GPT night token prediction. Yep. Maybe let me put it here. A second. Yeah. So I think many people are talking. It's not mainstream, but some people are talking about whether the current learning model are hitting the wall. So if you also think so, maybe you want to explore something alternative. For example, probably we should think like data, like architecture, like algorithm. The data, for example, for coding. There are lots of reliable information. For example, the syntax, semantics, compiler, those information. Probably we should collect those information. And say for coding, probably we shouldn't just do night token prediction. So probably we should do, like a word, a statement, a function, a class. This kind of hierarchy. Probably we should consider this kind of hierarchy to do the code learning model. So in this case, we need to change the architecture. We need to change the data, and for the algorithm, maybe for example, say reinforcement learning. Say if we do this way, I guess intuitively we may have a better model than just doing, say, post-training based on the current, say, GPT-5 or something, and they are building many things based on GPT with network computation. I think I did one thing probably should be true is probably this system will be more efficient and more effective, and maybe we can eliminate or even mitigate or even eliminate mistakes, because we in the data the training data we try to make them correct. Yes, so I think that's the advantage of using, say, reinforcement or something for pre-training. We do those reforms in pre-training stage from data, from architecture, from algorithms, rather than just do post-training of the current language models. Yeah, that's my understanding. Yeah.
Okay. The last question here is, the word model. The word model is crucial for AGI and even ASI. So how do we build a universal word model, and what applications would it generate?
Okay, that's a good question. I didn't mention this. Yeah, to me, I don't think a universal role model is a yeah. I don't think general intelligence, general agent, general role model. I don't think these are um, sound proposals. Yeah, consider this way. If you want to model something, there are lots of things to consider, right? And for example, there are even different level of granularity. Even if you say just for a single person, what kind of things you want to simulate, you want to model. Say what the role model of a single person. Do you want to model at the cell level, right? if you want to model at this level, how complex this model will be, that's just for a single person. But if you want to have a universal model, that means, there are how many people in the world, and there are how many things, how many, the interactions. So how can we have a very good, not to mention perfect, world model of the whole world, a universal one? So I don't think we should pursue that way. Probably we should, just focus on, some the world model for something, and then we try to improve it. Even so, the problem, just like mentioned, if we want to have a good model for a single person, or even just for a single, for example, physical system, that may be, for say robotics, that may be even very hard. Yeah, so basically that's my understanding of role model. We shouldn't do universal. We should do specialized. Yeah.
Okay. Yeah, I think that's all the questions for today's session. Thanks again to Dr. Lee for the amazing talk, and to all the audience today for your participation. We'll share the replay slides and the key takeaways on the website. So
Okay.
don't
Yeah.
forget
Yeah.
to follow. Don't forget to follow us on socials. Stay tuned for the upcoming episode. See you next week.
Yeah.
Bye.
Thanks a lot, and thanks for the question, and